In general, I used to do paintings and art and craft in my free time. Even best out of waste also I used to do that. While doing this one, when I observe some of the paintings, so in this manner, so really it is wonderful. I observed that in these figures, similar triangles, geometrical figures I saw. In birds painting and a lion, I have seen the similar triangles. And coming to this one also, doodles, and even in wall hangings also we can see the similar triangles. See how beautiful they are. And even in a meditation field also, they used to use these type of things to improve the concentration levels of the persons. So like this, several ways we can get these similar triangles in our daily life. So today we are going to get the similarity criteria in similar triangles. So let us see in what manner triangles can be similar to each other. In how many ways they are similar to each other. We know very well that two triangles are similar. If and only if when their corresponding angles are equal. And second one is corresponding sides are proportional. Suppose if I take in triangles ABC and DEF, if angle A is equal to angle D and angle B is equal to angle E and angle C is equal to angle F, and as well as AB by DE is equal to BC by EF is equal to AC by DF. So then you can write this triangle ABC and triangle DEF in this manner, that as here A is corresponding to this D and in B place E is there, C corresponds to F is there. In D place you can write A, and in E place you can write B, in F place also you can write C. So as it is one to one correspondence is there, so you can write symbolically in this manner. Triangle ABC is similar to triangle DEF, you can write in this manner. Here this symbol indicates the similarity symbol. You can use for similarity. To represent the similarity you can use this symbol. Okay, as we represented this symbol for the congruency, because the reason is this indicates the same in shape and plus equality indicates equal in size. Both in combined you can represent as in this manner for the congruency. So you can write this one, triangle ABC is similar to triangle DF, but we cannot write here triangle ABC is similar to triangle EDF. This is wrong. Because the particular vertex A is not corresponding to E, A corresponds to D. That is the reason. Even you can't write triangle ABC is similar to triangle FED also. As our wish we can't write it. There is a rule that we have to use that one to one correspondenceness. Even you can write it here BAC. If you take it, then you can write in B place E, and in A place D, and in C place what came? F. You can write it. This is correct again. So you can write the particular letters in a particular order according to their correspondences of their vertices. Even for this checking of the similarity triangles, actually we always check for all the equality relations of their corresponding angles and all the equality relations of the ratios of their corresponding sides. Let us recall the congruency axioms in the previous classes. Lower classes we have learnt about that. They are nothing but the one is SSS, SAS, ASA, RHS congruency axioms are there. So only these involves the congruency axioms of these two triangles involving only 3 pairs of the corresponding parts of the two triangles. It means totally we have 6 parts can be there in a triangle, in any triangle. Only we are comparing the 3 parts of it. Either 3 sides or the 2 sides, 1 angle, included angle, or else 2 angles and included side, or else in a right angle triangles, hypotenuse and the side. Like that we compare the only 3 parts. So let us make an attempt here to arrive at certain criteria for similarity of two triangles involving the relationship between less number of pairs of the corresponding parts of the two triangles instead of all 6 pairs of the corresponding parts. Let us take two similar triangles ABC and PQR. Cut these two triangles in such a way that angle A is equal to angle P and angle B is equal to angle Q and angle C is equal to angle R. In that manner you cut the two triangles. Now here place this ABC on this PQR. When you place on it, see here what we are observing. Here you see it comes like a, this as a BC is coming, here it is coming like a BC, and here A is, this A is coinciding with it, P. Understand? When you take here this as a B point and this as a point C, you join these 2 points. Now here you see this is the actually common angle we have taken, because this angle and this angle equal, and angle B is equal to angle Q I took. Here angle B is equal to angle Q came, and as well as angle C is equal to angle R. When you look at this figure, angle B is equal to angle Q and angle C is equal to angle R means what we can say? They are the corresponding angles. So can we say that this BC is parallel to QR? Yes. Now here you can say that this BC is parallel to QR. This is one case I am taking, case 1. And in other case, let us place over this triangle on it in this manner. It is coinciding with this one. So let us take these points. Now you draw the triangle. When you draw this triangle here, here R is coming, here P, and here is this is Q, PQR, and here I am coinciding this B with this Q. Here A is there, here C is there. Okay, these two are same, and this angle and this angle is equal, and this angle is equal to this angle. So here also you see this angle is equal to this angle and this angle is equal to this angle, you can say that these two also parallel to each other. Okay, we know very well that if any line drawn parallel to the one side of a triangle, then by the BPT theorem what we can say, it divides the other two sides in the same ratio. So this is case 2 I am taking. Let us discuss these two cases so that it is clear. Okay, now coming to case 1. This is the figure for this case 1. So in this one, you check this one. In triangle PQR, this angle B is equal to angle Q and angle C is equal to angle R, right? So by BPT theorem what we can say? By BPT theorem you can say that this PB by BQ is equal to PC by CR, you can write it. Or else you can write this one in this manner, that AB by, because A is at P, so AB by BQ is equal to AC by CR also you can write it, because in P place A is coinciding with it. So in place what we can write? This I am taking in a reverse manner, reversing the fraction, so I can get this one. Now I am adding 1 on both sides, BQ by AB plus 1 is equal to CR by AC plus 1. Here you write by adding 1 on both sides. So what we got it here? BQ plus AB by AB is equal to CR plus AC by AC. So when you add BQ plus AB in a figure, we are going to get that AQ by AB is equal to AR by AC. Implies, again take the reciprocal of it. Even first of all, before taking the reciprocal, you can write then AQ place PQ, I can write it, and by AB this is PR by AC, write it. Now take the reciprocal. Implies AB by PQ is equal to AC by PR. So this is the equation 1. Similarly, in the case 2 also, we are going to get in case 2, if you do in this manner, you are going to get in case 2, in a similar manner, you are going to get AB by PQ is equal to BC by QR. So from 1 and 2 equations, what we can say? From 1 and 2 equations, you can write this AB by PQ is equal to BC by QR is equal to AC by PR. So what we observed here, all the three sides of one triangle are proportional to all the three sides of the corresponding sides of the other triangle PQR. So from the cases 1 and 2, we can say that this triangle ABC is similar to triangle PQR. So according to our case, if the three corresponding angles of two triangles are equal, then their corresponding sides are proportional. So, and hence these two triangles are said to be similar. This is nothing but we can call it as AAA, AAA similarity criteria. We can call it as AAA criteria for the similarity of triangles. This is the criteria, one of the criteria of similar triangles. Let us cut two triangles ABC and PQR with their corresponding sides proportional. So, in this manner, like AB by PQ is equal to BC by QR is equal to AC by PR. In this manner, you take the triangles cutout and place this ABC triangle on this PQR triangle such that this A falls on vertex P, this is a falls on vertex P, and AB side falls on PQ side, and AC of this triangle ABC falls on PR. In that manner, you place this one small cutout triangle ABC on triangle PQR. When we observe these angles, when you measure it, you are going to get angle B is equal to angle Q and angle C is equal to angle R. This angle B is equal to angle Q, you are going to get it. Angle C is equal to angle R, you are going to get it. How is it possible? Anyhow, this P and A are at the same place, they are equal already. Understand? This can be equal. So, let us check how it is possible. When you join this one here, we are getting a triangle ABC on a triangle PQR. Okay. So, in this one, so what is given here? AB by PQ is equal to BC by QR is equal to AC by PR, right? So, in it, when I take this AB by PQ is equal to BC by QR. Now, you take also this is also equal to AC by PR, right? So, I am taking here these two, I am taking AB by PQ is equal to AC by PR. I am taking these two sides proportionality. So, now I am taking the reciprocal of it. PQ by AB is equal to PR by AC. Now, you subtract 1 on both sides. PQ by AB minus 1 is equal to PR by AC minus 1. Here you write the reason by subtracting 1 on both sides. Always remember, in geometry you have to write the reasons in the bracket. So, after this you are going to get PQ minus AB by AB is equal to PR minus AC by AC. From PQ, if we subtract AB in the figure, you are going to get BQ by AB, and from PR, if we subtract AC, you are going to get CR by AC. Now, take again the reciprocal of it. It becomes AB by BQ is equal to AC by CR. When you look at this triangle, in triangle PQR, this or else AQR, if you take it, this AB by BQ is equal to AC by CR means what we can say by using the converse of Bipit theorem. If any two sides are proportional in a triangle, then the particular line joining those 2 points, that is parallel to the third side. So, here you can write it that implies this BC is parallel to QR. If a line divides any two sides in the same proportional, then it is parallel to the third side, that is the converse of BPT, right? So, from this you can say that here in this figure, if BC is parallel to QR, what we can say? If this is parallel to this QR, you can say that this angle B is equal to angle Q, you can say, and as well as angle C is equal to angle R, as they are the corresponding angles, right? Anyhow, this is the common angle for both the triangles. This is the common angle for both triangles. So, you can write here, therefore, angle B is equal to angle Q and angle C is equal to angle R. So, you can write here the reason is corresponding angles. Why they are equal, you have to write corresponding angles. As angle A and angle P is at one place only, they are also equal. So, from this what we came to the conclusion, all the angles of one triangle are respectively equal to the corresponding angles of the other triangle. So, from this we can say that here we can come to the conclusion that this triangle ABC and triangle PQR are similar. When they are similar, if three corresponding sides of two triangles are proportional, then their corresponding angles can be equal, and also as well as they are similar. Here first of all you write that triangle ABC is similar to triangle PQR, you write it, and afterwards come to the conclusion with the statement that if three corresponding sides of two triangles are proportional, then their corresponding angles are equal, and also they are similar. This criteria nothing but we can call it as SSS triplus similarity criteria of the triangles. SSS similarity criteria. Let us take two triangle cutouts ABC and PQR in such a manner that angle A is equal to angle P and this AB is proportional to PQ and AC is proportional to PR. It means AB by PQ is equal to AC by PR, and as well as the included angles are equal. In that manner, let us take two triangles, and now you place this triangle ABC cutout on this PQR in such a manner that this A vertex falls on P and as well as this AB side falls on PQ side and AC side falls on PR. In that manner, let us take it. Now, when you check it here, as just now what we have taken, what I said, this AB by PQ is equal to AC by PR. That is, they are equal means by converse of Bipit theorem, what we can say, this BC is parallel to QR, you can say, as the two sides are proportional in two triangles. Actually, we can say that here this one is proportional, the third side they are parallel to each other. If they are parallel, you can say that angle B is equal to angle Q and angle C is equal to angle R. Okay, let us see how it is possible. So, when you take this one, when you join it BC, you are going to get ABC triangle and PQR. In this triangle, by actual measurement also you are going to get angle B is equal to angle Q and angle C is equal to angle R. So, in this what we have taken, first we started with AB by PQ is equal to AC by PR. In that way we started, and as well as the included angles are equal. Angle A is equal to angle P we have taken. Now, in this A Q R you can take, or else in A plus P, P plus A also you can use it. Okay, in this one, see, AB by PQ is equal to AC by PR is there. Okay, and here in it, in triangle ABC, sorry, AQR, you can take this AB by BQ is equal to AC by CR. When you take by converse of BPT, you can say that this BC is parallel to QR. Implies you can write it that angle B is equal to angle Q and angle C is equal to angle R. The reason is corresponding angles are equal, as they are corresponding angles. If the lines are parallel, then the corresponding angles can be equal. So from this what we can say, when you take the two sides proportional and one included angle are equal of one triangle is respectively proportional to the sides are respectively proportional to the other triangle and included angles are equal, then we can say that those two triangles are similar to each other, as well as this criteria is known as the SAS similarity criteria of the two triangles. Let us take here, before going to state that one similarity criteria, here you have to write it that as all the three angles are respectively equal to the all the three angles of the other triangle. A is equal to P, B is equal to Q, angle C is equal to angle R, as well as this AB by PQ is equal to AC by PR, and as well as this BC by QR. So you can say this triangle ABC is similar to triangle PQR because both conditions satisfied. All the sides are proportional as well as all the angles are equal, corresponding angles are equal. So you can come to the conclusion that if two sides of one triangle are proportional to two sides of another triangle, and the angles included between the two pairs of sides are equal, then corresponding angles of two triangles are equal, and also they are similar to each other. So this is nothing but we can call this one as the SAS similarity criteria. You can call this one as SAS similarity criteria. Okay, this is nothing but the SAS similarity criteria. In this module, we have learned about the similarity criteria of the two similar triangles. They are nothing but one is AAA similarity criteria, the other one is SAS similarity criteria, and also the SSS similarity criteria. Let us recall once again the definitions of it. AAA similarity criteria is nothing but if in two triangles the corresponding angles are equal, then their corresponding sides are in the same ratio. Hence the two triangles are said to be similar. That is known as the AAA similarity criteria. As well as if in two triangles, if two angles are equal also, you can say the third angle also equal by using the angle sum property. Suppose if in two triangles, if two angles are equal, then also we can say that two triangles are similar. That is nothing but the AA similarity criteria. If in two triangles, two angles of one triangle are respectively equal to the two angles of the other triangle, then the two triangles are similar. So these two are concepts are same. These two similarity criteria are same. And coming to the SAA similarity criteria is if one angle of a triangle is equal to the one angle of the other triangle and the sides including these angles are in the same ratio or else in proportion, then the two triangles are said to be the similar. Coming to the last but not the least, SSS similarity criteria is if in two triangles, if the corresponding sides are in the same ratio, then their corresponding angles are equal and hence the triangles are said to be similar. So we came to the end. Hope it is very clear to you all this concept. Meet you again in the next module.